Hi everyone, and welcome to Erik's Electronics Workbench. So on the bench today I have this ADCOM GFP-1A stereo preamplifier. So I recently picked up this preamp to use in my own audio system, but the story with the preamplifier is that it's not functioning correctly. So apparently there's a problem on one of the channels. I don't really know much beyond that, so maybe the audio is cutting out or it's distorted or an issue like that might be going on. We'll find out more as we work through the troubleshooting and see exactly what the fault is. Now, one of the first things that I noticed on the preamp is that it's in very clean condition. There's no scratches on the front panel, no dents or dings or anything like that. So it looks very nice. It was manufactured in the early 1980s. So for its age, again, it's in very nice condition. So it'll definitely be worth the time and effort to not only repair the preamp, but also restore it. I'm sure there's a lot of electrolytic capacitors that need to be changed and just general servicing. So we'll work through all of that as well. So let's get started. Okay, before I start in on the troubleshooting of the ADCOM GFP-1A, let's take a quick look at the front panel as well as the rear panel and just get an overall feel for the layout of the preamplifier. So right here we have the main power switch, and above that there's a little dot right here. Might be a little hard to see on the camera, but that's just the power indicator light. Next to that is the typical headphone jack, 1/4 inch TRS or tip ring and sleeve type jack. So this preamp does have a dedicated headphone amplifier section. Next to that, to be expected, the bass and treble tone controls along with a balance control. Right here there's two filter switches. You have a 25 kilohertz filter and then a 20 hertz filter, so useful for attenuating very low frequencies or extremely high frequencies. Right here this tone bypass switch is just for bypassing the tone section over here. And the mono switch is for taking a monaural input and just putting it on both left and right channels. Pardon the camera movement, just look over here on the right hand side. So right here is the main selector switches for the input as well as what you're recording on tape. So this has the ability to let you listen to one input while recording on a different input, so very versatile. You can see there's two phono sections right here, phono 1 and phono 2. So this does have two separate phono preamp sections. There's two tape inputs. You can see tape 1 and tape 2, and you'll notice there's no tape monitor loop mentioned on here, but we'll see why when we look at the rear panel. This reference right here to DAD/video, DAD is digital audio disc. That was a common term that you would see in the 1980s. Nowadays you would think of that as a CD input. Now over here there's a CX noise reduction right here, the switch. So I'll mention a little bit more about that in just a second. The typical loudness selection right here, you'd see that on most pieces of stereo equipment. And of course the main volume control. So the CX noise reduction was a very short-lived type of noise reduction, so admittedly not very useful nowadays. It's very unusual to come across an album that was actually recorded or encoded with the CX noise reduction. But a little bit about that CX noise reduction, if you're unfamiliar with that or haven't heard of it before, it actually stands for compatible expansion. And it was a system developed by CBS, or the Columbia Broadcasting System. And it's a noise reduction specifically or originally for LP records, vinyl records. But later on it actually found some use on laser discs as well as an attempt to use on FM broadcasts, but it was very short-lived on the FM broadcasts as well, but it did find some use on laser discs. So again, it was very short-lived on the vinyl records. There were not many records ever released with that noise reduction system on them. So finding that nowadays would be pretty rare. This preamp was actually issued originally with a test record for setting up the CX noise reduction. When we look at the back panel, I'll explain a little bit more about that. But that test record isn't necessary. You can actually calibrate this with a 1 kilohertz tone or 1,000 hertz tone, and that's mentioned in the service manual. So a unique feature about the CX noise reduction is that it could actually be played without a decoder. So of course this section right here with the CX is activating a decoder within this preamp. But if you didn't have that and you wanted to play a record that had CX noise reduction, supposedly you could do so, but it was debated if that it was actually affecting the sound or not. Some artists said that they didn't want to release their records with a CX noise reduction because they felt it was coloring the sound. So there was some debate early on about that. And again, it was very short-lived. It only lasted several years. Now, it was said that the CX noise reduction actually allows a 20 dBA of noise reduction within the system, and technically it's a 2-1-2 compander system. Now I'm curious to see when we open up this preamplifier what actually is involved in the circuitry for the CX noise reduction. There were some dedicated chips made by Hitachi and other manufacturers, and there could also be a CX noise reduction created out of discrete components. So it'll be interesting to see what was actually used within this preamp. Okay, taking a look at the back panel of the GFP-1A, you can see right here there's a binding post for a ground wire. This ground wire can be connected to a record player or a phonograph, and it's useful for eliminating ground loops and hum problems. So you can see the two phono inputs right here on these nice gold-plated RCA connectors. So phono 1 has a selectable sensitivity input for 2.5 millivolt or half millivolt, depending on the cartridge that record player would have. And then over here on phono 2, you can see down here it says the capacitance, and you can change the capacitance depending on the cartridge. Now up here is the CX calibrate. You can see it says under and over, and when you calibrate the noise reduction system, you're actually looking for both of these LEDs to be turned off. You can see it says left and right. There's a little potentiometer that you can reach through those holes right there and make the adjustment on the left and right channels. And again, the test record or the calibration record that was issued with the preamp would be used for that calibration, or it can be done with an external signal generator on a 1 kilohertz tone. Now, right here you can see there's a reference to the noise reduction system being under license from CBS Incorporated. As I mentioned, they were the originator or designer of that noise reduction system. Now, not too much exciting going on over here with the main inputs, typical that you would find on the preamp. Let me move this over just a little bit, pardon the camera movement. Now I mentioned that there's no tape monitor loop, and you can see right here there's a signal processor in and out. So this is just taking the preamp in the signal path and bringing the signal out right here, and then you could go through, say, an external equalizer or some other device and then return it back in right here. So it's nice that you don't end up using one of your tape 1 or tape 2 type inputs and using that up on an external equalizer or other device. So if you don't want to use an equalizer or something like that, you do need to jump between the in and out. If you don't have a jumper across here, then the signal path is broken and the preamp will not pass a signal all the way to the output. And of course the main output right here going to the power amplifier. It's important to note that the output 1 and 2, these are just in parallel, all right? So the left channel and then right channel, but then 1 and 2 again in parallel. And then over here you can see the AC outlets. For convenience, there's a switched and then an unswitched. See this one right here, 800 watts unswitched, and then right here we can see switched total of 400 watts. So I imagine that they're running this probably through the main power switch. It may go through a relay, I'm not sure yet. We'll see that when the cover is taken off. But this is useful if you want to switch a device like a power amplifier all the time when this preamp is turned on, just for convenience. And then you can have some other devices like a record player, a tape deck that can be unswitched, and then you can switch them manually. So just for convenience. And this does have a 16 gauge power cord, which is nice because they expect to have some load connected up here. This preamp draws very, very little current. I believe it says a 1/4 amp fuse. Where are we seeing this down here? Yeah, 1/4 amp right here. So a very light fuse in here, so this preamp of course does not draw much power at all. Alright, so the next thing that I'll do is remove the top cover. Let's take a look around inside the preamp, and if everything looks reasonable enough to power up the preamp, then we'll do so. If there's anything that looks, major wrong, where there's any bulging capacitors or something like that that needs an immediate attention before we power it up, then we'll do so. So depending on the physical condition and what we find in there, we'll make a decision and then continue on with the troubleshooting. Okay, so I have the top cover removed from the preamplifier, and there's several things that I noticed right away. So for the age of this preamp, it's very clean inside. There's almost no lint or dust, so that's a good starting point. The next thing that's pretty obvious is the large number of electrolytic capacitors. So all of these cans with the blue colored wrap that's on them all around here, those are all electrolytic capacitors, and really they need to be replaced at this point. A new electrolytic capacitor would outperform any of the capacitors that are in here by a fair margin. So for reliability, those all need to be replaced. Now maybe one of these capacitors has failed and that's causing the problem, I don't know yet, but nonetheless they'll all get replaced. Now one of the next things that's obvious is this brown colored glue that's in here. So you can see it around these capacitors, and I should say that none of the capacitors have leaked or are swollen, so that's also a good thing. But you can see this brown color that's around a lot of the capacitors that's also kind of holding down some of the cables in here and so forth. That glue is known to become conductive and corrosive, particularly when it turns a real dark brown color. So you can see in some areas it's kind of almost a lighter tan color, but like around these capacitors, particularly where there's a lot more heat over here in the power supply, very dark color. And we'll take a measurement on that glue, and I wouldn't be surprised to see if that's becoming conductive, and that's obviously a problem. So that new glue needs to be cleaned out, and it actually scrapes off pretty easily. And when you're replacing the capacitors, of course, you have access down in there. So that'll be something that needs some attention. Now the other capacitors in here, the polystyle capacitors, these little green ones, the ones that are somewhat clear colored looking, those are typically okay. So unless one of those tests faulty, they can be left alone. Now something else I'm noticing is that there's little heat sinks on many of the transistors in here. And let me zoom the camera in a little closer, you can kind of see what I'm talking about. So like right here, these two transistors have these little heat sinks clipped on them. Those are just plastic transistors like this one right there, but they've just added this little heat sink and it's just kind of crimped onto it. But what I'm noticing is that on a number of those heat sinks, it looks like they use that brown color glue under the aluminum, and it's actually causing the aluminum to become fuzzy and have some corrosion. Now I don't think it's going to hurt the transistor because it's plastic, but it is a concern because it's causing the corrosion on those heat sinks. It would be nice to see some heat sink compound under that aluminum. So I think what needs to be done is to actually remove these transistors from the circuit board and then uncrimp that heat sink and get that glue cleaned out of there, and then recrimp the heat sink on with a little bit of a thermal compound. Now, I would remove the transistor before trying to do that work, because if you're pushing or pulling it on here, you could easily break the leads off that transistor, so it'd be much safer to actually remove it from the circuit board. So again, that's something that after we do the troubleshooting, we'll take a closer look at that. But I'm also noticing a lot of the components have a kind of a awkward tilt and lean to them. I don't know exactly why they were a little sloppy on how things were mounted in here, but you can actually see that corrosion over here, see that fuzz on that one and how much of a lean that transistor has. So it'd be nice to clean those up so that they're standing upright again. Zoom the camera back out a little bit. Now, if you're following along, you're absolutely doing so at your own risk, because there are elevated DC voltages in this preamp as well as exposed AC line. So you can see over here, of course, the AC line comes into this area here, and then these two wires right here are bringing the AC line up to the power switch, which is in this corner, and it has exposed terminals on the back of that. So if you're working on something like this and you're following along, absolutely doing so at your own risk. Know the safety precautions that are necessary and be safe and take care. Definitely use an isolation transformer when working on something like this. Now the DC voltages on the power supply section and then the DC rail voltages throughout this preamp are somewhat elevated. They might be a little bit higher voltage than you would imagine. So the unregulated DC over in this section over here is 45 volts per rail, so it'll be about 90 volts across rail to rail. It's not something you would want to come in contact with. And then the regulated DC voltage that's distributed throughout here starts out at about 35 volts per rail. So again, that would be 70 volts rail to rail. And I believe it drops down a little bit through some dropping resistors and so forth later on, maybe closer to 30 volts or so. Just a quick look at the schematic had some numbers on it for voltages. Now, something else I should point out is that when you have a dual rail power supply, so you have a positive rail and negative rail and then a common ground, and the ground is the chassis. The negative rail, any capacitors that are on the negative rail, the can where you have the exposed metal top will be electrically hot. So you could get a shock if you're touching the chassis and you come in contact with the top of that capacitor. Something else I'm noticing, these two power transistors, which are part of the voltage regulator, have their heatsink tab mounted directly to these heat sinks, and the tab is usually on the collector. So that's going to be the unregulated side. So again, there's probably about 90 volts between these heat sinks, because that tab is probably electrically connected internally to the collector. Very common to do that. And then again, that's connected directly to this heat sink, and the heat sink is just floating or isolated, being mounted to the circuit board, so they can get away without having any insulation or any standoff between the transistor's tab and then the heat sink. So not something you want to come in contact with across here when this is powered up. We'll take a measurement on there and see if that's actually true in just a moment when I turn it on. So I'm not seeing really any other issues that would prevent this from being powered up, so we'll go ahead and do that, and I'll connect an audio signal to it, and let's see exactly what the problem is, what it's exhibiting. Before I do that, I should just mention the general layout. You might have already noticed if you were just kind of studying the circuit board. But you can see over here, this is the phono preamp sections over here, the two phono preamps, and of course there's a left and right channel. This is the noise reduction system, that CX noise reduction. Looks like they used a Hitachi HA12044 chip. So it's interesting, in this entire preamp, the only integrated circuit is right there in that noise reduction. Everything else is discrete components all throughout, so no op amps or anything like that. And then, of course, over here we come into the volume control section. There's some amplification section right here, tone control section over here. Looks like the headphone amp right here, and then of course this is the power supply section, transformer right here. All right, let me reposition things a little bit, and I will get some cables connected, and we'll see exactly how this preamp is performing and maybe what it's not doing correctly, and then we'll have an idea of where to start the troubleshooting on this circuit board. Okay, I have the RCA patch cords connected so we can get a signal into the preamp and then monitor the output on the oscilloscope. So I have my signal generator connected right here, the same signal on both the left and right channel going into the digital audio disc input. We'll use that as the test input. And the signal generator is set to 1 kilohertz. It's a 250 millivolt RMS sine wave. So we'll use that throughout the test. Right here, this patch cord right here is just that external signal processor looping from the output back to the input right here. And then this is the main preamp out going over to the oscilloscope, and I'll move the camera over to the scope in just a moment. Now before I turn this on, let's take a look at that adhesive glue that I was mentioning. There's some right here that's extremely dark, so you can see the digital multimeter over there for the continuity. If I touch the probes together, of course we can see that's just a direct short like so. So if I probe into the glue here, let's see if we have any readings. So the probes are not touching each other. Yep, it is becoming conductive. It's pretty high resistance. It's in the megohms, many megohms there, hundreds, but it is becoming conductive, and that'll only get worse with time. Let's try back here. Oh yeah, that's worse back there. Look at that. So again, the probes are not touching together. They're just into the glue. They're almost, I would say that's almost a 1/4 inch apart between the tips of the probes. It's a little over 100 megohms, 130 megohms. I can see a diode right here, and there's some corrosion on the lead to be expected with that glue. It really causes a problem. I don't know, something over here, there's some glue. It's not quite as dark. No, see, it's not becoming conductive. The probe's pretty close right there, and they're not showing any issue there. But usually when you see it get really dark like that, that becomes a problem. So that all needs to be cleaned up. So let's go ahead and power up the preamp, and we'll take a quick measurement on the power supply section right here, and let's just make sure we have the right kind of voltages on the power supply. So I'll turn my isolation transformer on. All right, so we've got 120 volts, we're good there, and power supply on. Yep, the little LED on the front panel is illuminated. You can't quite see that on the camera. I did hear a relay click. There's a little relay right here. It's probably keeps the output from having turn on thumps and things like that. So it clicked, so that's a good sign. So let's switch this over here to DC voltage. So I'll put one probe right here on the chassis. You can see that'll just be the reference right there. It's just touching the chassis. So I'll start by touching this heat sink right here. See what voltage we have here. Yep, 47, so I was thinking it was going to be close to 45, so no problems there. It must be the negative supply rail. This should be a positive for here. Yep, positive 46. So again, if you go across these two rails, these two heat sinks like so, you can see 94 volts, not something you would want to come in contact with over there. Now the emitter of these power transistors is the output going to the rest of the preamp. So let's take a quick reading there. That should be the regulated DC. Yep, 35 volts, that looks good. This one's a little trickier to reach back here. Yep, 35 volts, no problems there. So it looks like the power supply is functioning, no issues with the voltages. And I was mentioning, if you touch one of these cans, yeah, see right there, the top of that can is electrically hot. That one is floating up just a little bit there, but the negative supply on that side. All right, I'll switch on the signal generator. And let's see what we have on the oscilloscope. So pardon the camera movement, I'll swing this over to the scope display. So we can see there is an issue because you can see by the colors over there, the red and white patch cords coming into the scope. That's the left and right channels. So channel 1 being left, channel 2 is the right channel. And we do have a sine wave on, it looks like channel 1, but absolutely nothing on channel 2. So the right channel looks like there is an issue. So I'm going to vary the volume control. Yeah, no issues there with the volume control. That's working very well on that one channel, but definitely a problem on the other channel. There's nothing. I'm going to move a couple things here just to see if there's any intermittent connections. Let's try the input selector. It comes back in, but the one channel really has no activity whatsoever. So that's the balance control. I'm going to one side and then the other. No, that one channel is not really changing at all. So the volume has some effect there. None of the other switches seem to be doing much as far as causing any activity on the other channel. Tone bypass, nothing's happening there. Nope, nothing's bringing up the other channel. So that gives us an idea of where to start looking. Definitely an issue going on the right channel. So let me reposition some things so that we can start to probe through the circuitry on the right channel and see if we can track down where the problem is. So whenever you're attempting to troubleshoot a problem like this, you want to take an organized approach to what you're doing. Of course, taking random measurements all over the place won't get you anywhere. It can lead to a lot of frustration, and you can easily miss where the problem is. So you want to have something that's an organized way to tackle where the problem is actually located. And there's really three ways you can go about doing that. So you can start at the input back here where we know we have a signal coming in, and you can take a measurement there and then go through the circuit and start, another measurement, and work around until you get to the output. And at some point we know there's no signal at the output. Somewhere in the path there must be a break in the circuit, defective component or something like that. And when you find that location, there's your problem. So that's one way to do it. Now you could also start at the output where you have no signal and start working back through the circuitry, and when you get to the signal, of course, now you've found where the problem is. So that's another approach. And then the third way is to basically start somewhere roughly in the middle, maybe over here in the tone section, and then you could just take a measurement there, and let's say you do have a signal. Well, then there's no sense in going further back to where you're putting in the signal because you already know you have the signal. You would start there, you say I have a signal, okay, let's continue towards the output, and then when you don't have the signal again, maybe it's in the main output section or something like that, then you found the problem. And if you were to measure here and say, oh, there is no signal, then continue backwards that way until you do find where the signal is. So really three kind of approaches. And the one that I really prefer to use is the one where you start at a known input where you have the signal and start working through the circuit and then work towards the output where you already have no signal. So that's what we're going to do here. Now, ADCOM really has a couple nice features that they put on the circuit board. The silk screening on the board is really nice. You can see kind of just the overall layout in here. You can see these on the silk screening, this bluish kind of green sort of color that's in here. But that's the traces that would be on the back side, and they've silk screened where those traces are on the top side. So it makes it really convenient when you're looking at a component. You can actually see what it's connected to and where the trace would go. So very nice for troubleshooting. The layout that ADCOM used for their component numbering is because you do have a stereo layout where you have a left and right channel that are identical. They use the same numbers for the components on the left and right channel, but they put an L or an R after the component when it's unique to one channel, and things that are over in the power supply that are common to both channels, they don't have that L or R after them. So again, you can look at a component and know if it's on the left or right channel. Makes it very, very nice for troubleshooting, and of course those same numbers appear on the schematic. So let's take a quick look at the schematic and see exactly where we need to start taking some measurements. Of course, just for reference, I'll take a measurement right here at the other side of this input jack, because we don't want to overlook something. Maybe there's a problem with the input jack, something simple like that. And then if we do have a signal there, of course, we'll continue on through the circuitry. So let's take a quick look at the schematic. Okay, here's the schematic for the preamplifier. I don't have a printed copy. It's in the computer, so we're actually looking at the laptop screen right now, but I think it should work okay on the camera. Now, this schematic, unfortunately, is not the sharpest scan. When you actually zoom in, some of the lettering and numbers are actually pretty hard to read, but after some studying, I've been able to decipher exactly, the numbers 8s and 0s and 6s all tend to look the same. So we can see over here, this is actually the inputs over here. We can see the external processor right here. They're showing those jumper loops that need to be connected. So I'm using the digital audio disc input, and that's actually represented up here. Okay, so we're putting the same signal in on both of those channels right there. So let me scroll this over. Pardon the jumping around here while I get this moved over into position. But you can see all of these lines that come through here. These are all going up to those selector switches and the record switches. And what we will do is take a measurement. Looks like a reasonable place to start. Get this positioned here. So again, they're showing the left and right channels here, and on one side they have all the numbering, and then down here you can see there's components without numbering, but these channels are just duplicates of each other. So we can just look at one channel, even if it's left or right, it doesn't matter on the schematic. So you can see right here the selector switch that you select for the input that you want comes through the loudness control right here. And the other side of the loudness control has the volume control right here. And then the first active component is this FET, okay? We have a differential amplifier right here, 2 FETs. So it seems like a reasonable place to take a first measurement after the input jack would be the gate of this FET. And it'd be nice to see a signal there. If we don't have a signal there, then we know there's a problem in the volume control, or possibly something going on over here in these few components for the loudness control. But we'll take a reading there and see if we have a signal, and if we do, then we'll work through this section and continue on. And you can see this basically comes through this path this way, and then if you move over a little bit further here, the signal comes down like so, and then continues on down into some more circuitry down here. So we'll just follow that path, and then we'll see where the signal disappears at. All right. So what I'm going to do is put the camera back over at the oscilloscope so that you can see the actual signal that I'm measuring, so that I'm not moving the camera back and forth between the circuit board and the schematic and the oscilloscope. It's a lot of camera movement. So I'll just keep it on the oscilloscope, and then I'll let you know what component I'm actually taking the reading at. Okay, let's start by taking a reading right at the RCA jack on the back panel where it enters the circuit board. So here's the right channel. And we do have a nice looking sine wave there, so no problems with the RCA jack. We're getting a signal right to the circuit board. So let's move over to that first active device, that FET. We'll take a look at the gate of that FET. Let's see if we have a signal there. If we do, we know that the signal is making its way through the volume control and through some of the loudness circuitry. So that FET is Q301R. So let's take a look at the circuit board here, Q301R right here. And we do have a signal there, so that looks very good. So I'm rotating the volume control, no problems there. That noise that you were seeing on the waveform is just the probe not making contact right there. But rotating the volume control looks fine, no issues there. So we are getting a signal into that FET, so that shows that the volume control and the loudness circuitry is all working correctly. So we have some stages of amplification, and the signal should appear at a considerably larger value at Q305, it looks like. Again, a little bit hard to see on the schematic, but looking at the circuitry on here, Q305 makes sense for that part number. So Q305, and the signal would be coming off of the emitter. So if I can reach the probe down here, looks like the emitter is right here. Oh yeah, we have a very large signal there. Let me turn the volume control down. Yeah, so there's no issue at all. Now again, this is the right channel that was giving us, you know, the trouble with absolutely no output, but you can see a lot of amplification going on there, no problem whatsoever. You can see that I changed the setting of the volts per division on the scope. I could make that go much larger, but not having any issue whatsoever. I had to back the volume control down considerably there to keep that from going off of the top of the graticule. So that looks very good, but there's clearly a break in the signal path somewhere because we had absolutely no output. So the output from that emitter will pass through two electrolytic capacitors that are back to back. It basically makes a non-polarized capacitor. It goes through, looks like a resistor, and then there's another 1 megohm resistor going to ground, but it ultimately comes over to the balance control. That's the next device that it really passes through. So the balance control on the right channel is very close to the front panel here. In fact, I don't think I can get the probe on it the way it is. I may need to take the bottom panel off. Yeah, I'm going to need to take the bottom panel off to even get to the traces on the circuit board. So let me do that, and then we'll take a reading at the balance control. Okay, I have the bottom cover removed from the preamplifier, and that'll give access to the traces on the circuit board where the balance potentiometer is located. So I'll zoom the camera in a little bit closer, and you can see, if I go about here, this up a little bit. So that potentiometer is right there, and the right channel is tucked up against the far edge of the circuit board that's under the lip of the chassis right there. So I can get the probe of the oscilloscope onto that point. We'll take a measurement there. So let's go back over to the schematic. So just to review where the measurements were taken. So the gate of this FET had a very good signal, no issues going on there. And the emitter of this transistor right here had a very large signal, so a lot of amplification going on in this stage, so no problems there. So we have two back-to-back electrolytic capacitors right here, and then this is the balance potentiometer. So this potentiometer here and down here would be ganged together. The same with the volume control over here, the wiper on the volume control, potentiometer there, and there, those are ganged together, they're moving like so. So I'm going to take a measurement over here at the balance control, because if we have a signal there, then we know this, you know, it's making its way through those capacitors, and then of course through the balance control, and then the next thing would be this switch right here, which I believe is the tone bypass section switch. So we can move on to that area of the circuitry if we do in fact have a signal here, so we'll check that next. So let me move this back over to the oscilloscope. Alright, so that's the wiper of the balance control potentiometer on the right channel, and there's absolutely nothing there. Let's make sure the volume control is increased. And the volume control is absolutely maximum. It looks like it's trying to put something there. The trace wiggles a little bit, but for comparison, let's take a look at the left channel at that point. Oh yeah, look at the left channel by comparison. So right there, keeping the volume control in the same position, that's the wiper on the balance control for left channel. And there is the right channel. Absolutely nothing there. So very interesting. So there we're getting very close to where the problem is. Let's take a look at the balance control. One side is connected to ground, and the other side is basically where the signal is coming in. Very interesting. So that's the side of the potentiometer where the signal is entering. So it looks like the balance control potentiometer is defective because there's no signal at the wiper, but there is a signal present coming into it, and then the other side is just connected to ground. Yeah, that's normal right there. There's no signal there. That's a little bit unfortunate. The potentiometer, I don't know if that'll be a tricky part to find or not. Sometimes the potentiometers are specially made so that they fit the chassis, you know, correctly with the length of the shaft and maybe how it fits to the circuit board and so forth. Sometimes manufacturers have those potentiometers specially designed, so I'm not sure with this situation if that's going to be the case or not. It looks like that potentiometer is a 100 k ohm, so pretty common value. So we'll have to take a closer look at that potentiometer. That needs to be removed, and we'll see if that's something that can be repaired or maybe it needs to be replaced. So again, looking at the schematic, here's that balance control potentiometer. and you can see one side is connected to ground, so of course no signal at that point, but there was no signal at the wiper right here. We do have a signal at the top of the potentiometer, so the signal is making its way through these two back-to-back electrolytic capacitors. There's a 1 megohm resistor to ground right here, there's another resistor right here, and then it comes into the potentiometer. So no issue with the signal at that point, but it's not making its way to the wiper. Even when that balance potentiometer is rotated, there's never a signal appearing at the wiper. So that's the middle terminal on the potentiometer. So something is, clearly defective within that potentiometer. Interesting, because the balance potentiometer wouldn't be moved that much in relation to something like the volume control. So I can't imagine it's worn out, but it clearly has no continuity through that potentiometer. So definitely needs to be looked at. Now, maybe I can open up that potentiometer and, possibly repair it or see what has happened. Usually if they get dirty, you get some intermittent, activity as you rotate the control, but in this case, it's absolutely an open circuit, at all positions. If I can't repair it, or something is, broken to the point or worn out, or whatever the case may be, then I'll have to see if I can find a replacement, something that both fits to the front panel correctly and also reaches to the circuit board. So we'll have to see how that works out. So I hope you enjoyed the troubleshooting that we've done so far in this part 1 video of the ADCOM GFP-1A. And if you've enjoyed this video, don't forget to give it a thumbs up. And remember to subscribe to this channel. There'll be a part 2 video where we'll continue on with the servicing of this preamplifier. And there'll be many more videos like this of troubleshooting, repairs, and restorations. So if you're into those types of topics, please remember to subscribe to this channel, because there'll be a lot more content coming up. So until next time, take care and goodbye for now.